Hello, everyone. Welcome to BAKERpedia seminar, all about hamburger bun production. We have a packed schedule today and one of the highest signups we've ever had. So it's important that we get to everybody's questions today. All right. I'm Dr. Lynn Carson, your host for today, and we have Ashuni Perez behind the scenes as the moderator. So welcome, everyone. This seminar is brought to you by our sponsors, Goodway Technologies and KPM Analytics. Goodway Technologies has over 55 years of providing innovative maintenance and sanitation solutions. Goodway Technologies has the industry's most reliable surface and conveyor belt sanitizing equipment for robust hygiene and food production plants. Industrial bakeries, snack producers, produce processing facilities, and breweries are just some of the places where sanitation professionals can find Goodway's high-quality machines. Are you still using water to clean? If so, check out their website, goodway.com, to learn about the innovative rapid steaming equipment, because you do not want to have water everywhere in your plant. All right. Our next sponsor is KPM Analytics. KPM Analytics supplies instruments that measure critical quality parameters of incoming ingredients, analyze products during the baking process, and ensure final product quality. Their comprehensive range of analyzers are used by food producers throughout the production to improve efficiency. KPM Analytics is backed up by over 100 years of experience developing advanced products and processes for quality assurance and process control in baked goods manufacturing. If you need any kind of QA help, contact kpmanalytics.com. Now, today we have three amazing presenters. We have Evan. Evan Riaz is the Global Director of Sales, Sanitation Division for Goodway Technologies, a global leader in industrial maintenance, cleaning, and sanitation solutions. With over a decade at Goodway, he has positioned himself as an industry expert on food safety and sanitation best practices. Evan brings hands-on experience from hundreds of visits and product demonstrations in food and beverage production plants for Goodway Solutions. Solutions that include innovative dry steam generation systems, specialized industrial vacuums, and pure belt automated conveyor belt cleaning solutions. Now, we also have Andrew McGee. Andrew has over 30 years of experience in the baking industry. He has a Bachelor of Business from the University of Technology in Sydney, Australia, and joined the bakery industry in Australia in 1987. When Andrew arrived in the US, he joined Northeast Foods in Baltimore, working for the Patarakis family in the bakery, supplying McDonald's restaurants. So Andrew knows his buns, okay? Andrew then worked for iPro System inspection systems for bakery products for 10 years, heading up the North American operations before joining Schaefer Mixers, part of the Bundy Group in 2017, where he heads up the sales team. Andrew has rejoined iPro Systems, which is now part of the KPM Analytics groups, which includes iconic bakery equipment such as Chopin, SensorTech, Process Sensors, Sightline, and Unity. Last but not least, we have Lena Bosk-Byrne. Lena has an education in engineering and food science, specialized in the cereal industry. She works for Chopin Technologies, now part of KPM Analytics since 2014. For more than 9 years, she occupied different positions and now manages the food products and applications team, whose role consists in ensuring the application development and the promotion of Chopin products. They provide personalized solutions to customers willing to improve control of their products and processes. Lena's responsibilities also include the standardization of the developed methods, working closely with various associations such as ISO, AACC, and ICC. Now, let's get into the thick of this, and Evan now will share a presentation on sanitation. Evan?
All right, Dr. Lynn, thanks so much for having me on this webinar. Really excited to go through some of these slides, and thank you all so much for being here. So I'll just jump right into it. First, a little bit about me. Dr. Lynn mentioned I've been with Goodway for about 15 years now, working primarily in the baking industry for the past 12. And my job for a long time has just been to visit bakeries and help them strengthen their sanitation programs. So Goodway, our philosophy, we're here to help our customers in the baking industry strengthen quality and food safety through the introduction of and implementation of better cleaning and sanitizing practices. So we specialize in everything from automating conveyor belt cleaning to helping our customers solve the unique cleaning challenges within their facility. We have a team of sanitation sales experts all over the world that help our customers with on-site visits and consultations, then follow up with demonstrations of the product and training and support to make sure that our customers really see the value in the equipment that we're hoping to provide. Customer satisfaction is really important for us, and we strive to be a cleaning and sanitation equipment partner that really adds value for our customers instead of just selling machines. We're headquartered in Stamford, Connecticut. We have about 140 employees all over the world, as well as offices in the United Arab Emirates, in Germany, Italy, UK, and several distributors throughout the world that help us to cover other countries as well. So getting into the actual solutions that we work on closely with the baking industry. Over on the top right are dry steam cleaners, the conveyor belt cleaning systems. In the center, we'll talk about quite a bit, industrial vacuums, and then allergen management and preventing cross-contamination. So we'll take a quick look at the current market and what practices are currently being used that we see for conveyor belt cleaning, look at some specific solutions for conveyor cleaning and hamburger bun production, and what are the advantages, look at a case study and how to get started and all that good stuff. So typically when we walk into a bun plant, we see bakeries either do one of two things. For a quick cleaning, they'll typically blow conveyors out with a compressed air gun or wipe them down and then spray a sanitizer. Or periodically, maybe every 3 months or every 6 months, we see a lot of conveyor belts being removed for cleaning, very labor intensive and time consuming. For spiral coolers on a bun line, we see a lot of wet cleaning and full wash down, which all kind of leads to a lot of labor, downtime, subpar cleaning results for when we're just using an air gun. The debris gets in the air and lands elsewhere. Also a potential introduction of micro load after wet cleaning and yeast and mold growth due to just excessive amounts of water that's introduced in the bakery through wet cleaning. So some solutions that we focus on to help the industry is particularly our Pure Belt modular belt cleaner. This is really a home run at a bun plant. It works so well to clean conveyor belts in place. We use dry steam in combination with some robotics that we mount onto the conveyor to clean the belt hands-free. The steam is able to penetrate more deeply into the cracks and crevices on the conveyor as it runs underneath. The heat transfer from the steam also reduces yeast and mold counts on the belt surface, and it introduces no water or potential microgrowth into the environment. So it's a dry cleaning. The system is portable and adjustable to fit a variety of belt widths. And it'll remove any breadcrumbs, sesame seeds, oil, dry debris that's on the belt, and blow it down onto the floor into a catch pan. We also see significant yeast and mold reduction. A lot of our customers will use this in the summertime to help keep their yeast and mold counts down on their belts and reduce customer complaints. So really for a bun producer, this is technology that could save a lot of time, increase the cleaning efficacy, and promote better product quality and food safety. So we have labor savings, so we're able to free up sanitation and maintenance personnel for other tasks versus removing belts or cleaning them by hand. We see an increased production uptime. We reduce the sanitation times, and because it's a dry cleaning, you don't have to wait for a spiral cooler to dry after a wet cleaning. So we significantly reduce the cleaning times, increasing the amount of time we could have production running. We're able to effectively remove allergens from the belt surface. So we validated with several customers of ours the removal of tree nuts, sesame, and dairy that some of our customers in bun production have struggled to remove from their food contact surfaces on conveyor belts. So we're able to do an allergen level clean on these types of soils. The system introduces no moisture, belts are left completely dry, reducing yeast and mold potential. Because it's a hands-free cleaning, we reduce strain on operators from kind of manual cleaning, and just decrease their exposure to chemicals as well. And the automation is able to do a very consistent, very thorough cleaning. So here's a case study at a bakery in the Northeast. They were cleaning their belts weekly, and they needed a lot of personnel from sanitation and maintenance to remove their conveyor belt in sections. There's no way to wet clean it in place. They're removing it in sections. Took about 120 hours of total labor time every week to remove those sections, hand wash them, rinse them, sanitize, let them dry, reinstall. So they went from doing that to using one of our belt cleaners right in place on the line, and we're able to significantly reduce their labor to clean the belt, leading to 95% labor savings, and just decrease a lot of the unnecessary time spent in disassembling and reassembling and cleaning and drying. They were also able to use the steamer for many other applications besides just conveyor belt cleaning, but this was really the most obvious return on investment for them and benefit that they saw in their bakery. So ways that we help our customers calculate potential labor savings with this type of technology is we review the cleaning programs that you have to see, okay, for this particular conveyor belt, what's the amount of downtime? How many people does it take to clean times how many hours? How long is a water hose open when you're doing that cleaning? What type of chemistry are you using? And we help to get a current state. And then we compare that with the estimated amount of labor, downtime, and water used after using the dry steam cleaning, belt cleaning systems. And we take that difference, multiply it out by a year over however many cleanings you have in that particular period. And we're able to help our customers produce pretty accurate return on investment analysis before they consider implementing the equipment in their bakeries, see if it's right for them. This is something we help our customers with every day and would look forward to helping any of your facilities with. So how to get started, please give us a call anytime. We offer free on-site demonstrations of the equipment where we come in, send a sales expert to assess the current applications where we might be able to help, show you where the equipment could add value, then come on site and demonstrate it for you and validate the cleaning and the results that we're able to achieve. And then from there, if you choose to purchase it, come back for training and support and service and that kind of thing. We do custom engineer our equipment. If you have we see a lot of spiral coolers that have challenging access and different things like that. So we're able to customize our systems to fit into tight areas. So that's always a possibility we look at whenever we're working with a customer. And we look forward to potentially helping your bakery. So thank you so much.
Thank you, Evan. Next, we would like to have Andrew present. Andrew.
No problem. Let me struggle with the technology and get it going here.
Not a problem.
In good shape. See the screen, I hope.
Yeah.
So I'm setting a timer so I don't talk too long, because otherwise I'll hear you guys snoring at the other end, and we don't want any of that. Okay. So today we're going to talk about bun production and what tools that iPro, which is part of KPM on the vision side, can provide to you to help you with your goal to deliver the best quality to your customers, to be very efficient in that production as well. So just a quick summary of KPM. So KPM is the parent company of 9 brands, and you can see the 9 brands at the bottom here. We have a pretty heavy presence in vision. So we have Sightline, which is has done a lot of bakery in the past and doing a lot of protein inspection systems. Smart Vision Works, which is doing a lot of in potatoes, vegetable and meat processing, doing a lot of AI vision, detecting foreign materials and grading a product. And then there's iPro, which is primarily dedicated to bakery, so has been doing so for over 20 years. We have a global presence with offices all around the world, and we have over 50,000 installs. Let's talk about buns. Now, let's begin at the end, okay? At the end, we have a finished bun, and we want to know, okay, is this meeting our customers' needs? So there are a lot of things that we look at when we're measuring buns, and I've just made a quick list here. But the challenge is that on the call here, I'm sure there are people that are using very manual systems to produce buns, taking the dough pieces off the molder and putting them by hand on the baking pans and producing them that way. And then you have other places where they have 7,000 dozen an hour buns, highly automated. Dough balls are being sheeted and deposited into the pans automatically. Now, all these processes have a need to try and control that process as best they possibly can. And Vision can provide a tool to help you do that. So you can see here that in bun production, I've got a whole range of products that we can look at. Single buns, but also clusters, hot dogs, hamburgers, and then even some artisan products as well can all be inspected and quality validated using Vision. What is most important, there are a lot of things you can look at, there are a lot of things you can measure, but what's very important is to focus what's important to your customer, to keep them happy and make sure you're delivering the quality. But also there are attributes that within your production process are very important to make sure that your line runs well. So if buns are consistently too big, they could jam up the packaging, they might not fit into the bags and things like that. So there's a two-way benefit here: deliver more consistent quality to your customer, but also help you in your production process. Now, I know what you're doing because I used to do this in Australia in the bakeries. We used to take half a dozen or a dozen buns off the line every half hour. We would get the caliper out, we would weigh them, we would get the caliper out. Might even have a colorimeter if we were being really sophisticated and measuring the color on the top of the bun. And then we were writing it down on a piece of paper, and then somebody was probably keying that into a spreadsheet to come up with some report that we could look at and understand what was going on. And we thought we had a pretty good idea. We even did the calculation to make sure that we were sampling, statistically valid sampling of our process. And then eventually, when I came to the States, we started using online vision systems. And I have to say that once we started using online vision systems, it blew my mind, because where you thought you had a good picture of what the variation in your process was, when you actually got an online vision system inspecting 100% of your product, then you really knew what the range of variation it was. And it was really kind of scary. It was like, wow, we thought we were here, but in reality, we're out here. The good news was that yesterday, before we had the online vision system, we were still had the same process and the same product, and we were sending it to our customers, and by and large, they were happy. So nothing actually changed. It's just that now we had better information about our process that we could act upon. So what we're using in vision systems is different configurations for different lines of different products. But usually it's a high resolution color camera. We can do top and bottom inspection. We also can use a 3D camera to measure the height of the product, measure slope on the product. As I said, online systems, it's 100% inspection. And then we're also in real time displaying the measurements, the statistics. We're also identifying any defects of the product and itemizing the cause of those defects. And then we can also use that information to correlate with different parts of the process. And I can talk about that later. Now, if often as a starting point, people go from there manually taking samples and hand measuring with calipers and putting it into a spreadsheet or writing it down. We'll have a standalone system, which is a very valuable tool. What this allows you to do is to still take the samples off the line, but then run them through the vision system, the standalone vision system, and record data automatically. You can see here we have a scale, so we can weigh the product and then run the products through the system. The system automatically measures the weight and the measurements and puts it into a report so you can correlate the data. It then gives you statistics about those sampling that you've been doing for each batch and then for over the whole day. So again, you can very quickly, you can actually run more products in the same amount of time and get better data. And also the data is always there. It's not on paper, it's not even on a spreadsheet. It's in a database that you can then query and generate reports from. Online inspection systems are a couple of examples here. So as I mentioned, every product that comes out of the line is going to be inspected. And again, you're getting a very detailed profile of what you're producing. And it can have a rejection mechanism. So if something is not what you want to send to your customers, it can be automatically rejected off the line. But some customers are just looking to monitor their process and understand their process. Here's a video that I'm going to show you of. I'm going to speed it along a little bit so we don't waste a lot of time. So this is, a bun line. I think this bun line is producing 3,000 dozen products an hour. You can see there the red laser line that's going over the product. That's part of the 3D imaging that's actually giving you a detailed height profile of the product. Okay, I'm going to move along a little quicker. We also are using a color camera on the top of the product, and then a color camera looking through a gap in the conveyor for the bottom of the product. And that allows us to get 3 images of every product: a color image of the top, a color image of the bottom of the product, and then a 3D profile of the product. And from that, we can collect a lot of data. Here you can see we have some histogram data on height and other measurements. We actually save images of any products that are rejected, and you can click on that image and find out exactly why that product was rejected, because what happens is your boss is going to stand there and look at a product come off the line and go, this looks pretty good. What's the problem? Oh, when I open it up, I can see, okay, this is the heel image here. And you can see that this product has white ring, and perhaps we don't want to send white ring out to our customer. This is the gap in the conveyor where the camera is looking from below to see the heel of the product. And from that, because it's a line scan camera, grabbing one row of pixels at a time, we can actually see the whole heel and analyze the heel. We can analyze the edge color separately from the body of the color. And then you see the product going down this chute. The good product continues down the chute. The product that you want to remove from the line is actually ejected off the line onto a transverse reject conveyor. And again, we say that the reject mechanism is just the insurance policy, just to make sure that the bad product that you don't want to go to your customer doesn't go to your customer. But really, the vision system is all about information. Here's some examples of different rejection mechanisms. That's the flat mechanism that we're using for buns. Tortillas, we use air nozzles. For baguettes, we can use retracting conveyors or declining conveyors. In this case, on bagels, the doubles are being rejected to one location to be recirculated and broken, and the rejected products that are no good are going to be rejected to the far conveyor and then not sent to customers. Join. This is just a quick summary of the architecture of the system. So basically, this is the color camera with the lighting, a high efficiency LED lighting system. Then we have the laser line with a 3D camera. And then we have the lower camera looking up from below. Okay, this is the profile on the 3D color image, but you've seen that, and you can see that we can get very detailed information about the products. I'm going to skip over that slide. Well, actually, maybe we'll do it. This just is showing you some of the things that we can look at. We can look at diameter, length, width, roundness. We can see sesame seed coverage. Is it there? Is it the right color? Is there enough of it? Here we can see a detailed 3D profile of the product. Vision process control is also something that we're looking at very importantly now. Throughout the process, your process, there are different steps where we can look at something, look at that part of the process and see if there's an issue that may cause you problem with the finished product quality. Because right now, often our inspection systems are right at the end of the production line. And as you know, the production process can be 4 hours in total. It could even be longer depending on the product. And so knowing now that I have a problem means, oh gosh, I could have 3 or 4 hours worth of production that I have to not send to my customer. So at different steps here, we can have different processes to, so like at forming, we can have an inspection system checking the dough height, the length. In the proofer, we can check that after the proofer that the product's properly proved or that seeds are being applied. In the baking process, we can actually look at the color of the product as it's coming out of the oven, and we've actually had the feedback loops where we can actually control the last 2 zones of the oven to automatically control bake color, and that really helps, especially in times where we're having trouble with finding qualified labor. Helping to automate a lot of these processes, or at least having an automatic feedback loop to help us in controlling those processes is very valuable. And as I've said a number of times, data is the most important things. So real time, I'm getting a lot of trend graphs and information that I can then monitor my process. I can also, when I make a change, I can see, okay, did that change actually improve what's going on in the bakery? And this is an example of forming, proofing, baking. And these are examples of systems in different parts of processes on the line where we're doing some monitoring. There's no rejection after the proofer. It's just monitoring and setting off an alert if there's a problem as far as how things are running. This is a finished product inspection here. Reject bad products. This is on a donut line, checking the shapes and positions of the product. This is an automatic control of a bake oven in a cookie line. Again, helps to get very consistent product. It can automatically react to changes in circumstances and really help to eliminate waste. Information is the key. We talked about that. This is a graph here that I like to look at. This is height, and you can see here the peaks, the sawtooth. This is basically correlating to each batch. And what we found is there was a height, when we first started doing this 20 years ago, that there was a high correlation between height and bake color. And we're getting a lot of variation. So what we ended up doing was in the bakeries, we ended up doing smaller batches more often, and we're able to still have a variation, but it was a much narrower variation. It was much more acceptable. This is a trend graph of waste. This is the images of the rejected product. This is actually a Pareto analysis telling you where your waste is coming from or where your defects are coming from. So that's a very powerful tool. Looking at the largest column is always what you do, and work from there. Wanted to talk quickly about some of the futures of vision. The most important thing, like everything, AI is becoming a really powerful tool. We've always used it, but with a great increase in processing power and algorithms, we are now using it much more powerfully in our systems. It has the ability to help us detect defects. It also has the ability to help make the systems easier to use and easier to set up new products. And so that's really important as well, because we don't want to have rocket scientists having to run the vision systems. We want to make it still very easy for the operators, number one, to understand the data, but also to be able to work with the data, set up new products and things like that. So that's where AI is also helping us with that. This is one of the things here, flour on heel versus the steam hole is a big issue. So being able to detect those two is very hard visually. Just for a camera, they're both wide, they both can be a similar size. That's quite challenging. But using AI, we're able to very easily be able to distinguish the two. This is an example of we're actually using a green backlight here to also enhance the image to be able to see any defects. But this is, I'm going to show you, go straight to this here. So you can see here we have steam holes, which are okay, but we have some old dough on the bottom of the plug. So AI is able to distinguish the two. You can see that this is a defect, but not picking these up as defects. Same here. This is old dough, steam hole is okay. So very powerful tools. And finally, just want to talk about foreign material is on the tip of everybody's tongue. Your customers are very concerned about it. Consumers are very concerned about it. So another tool that we can use that as well as AI is hyperspectral imaging. And what that is, it can see different products that are made of different components very clearly on a food background. So for example, here we have paper, rubber, wood, and plastic. So on a pizza topping line, it's very hard visually, just using a color camera to see it. AI can help us to distinguish it a little better, but still not great. But using the hyperspectral, which is looking at a different part of the spectral footprint of these products, on these foreign materials, these are very different from the background of the food. So when we are looking at using that specific sensor, these just shine out very brightly. Now, it doesn't work on all foreign material, but a lot of the common foreign material that you might have trouble with in your facilities, hyperspectral can be a very powerful tool. It is quite expensive, but then what you have to think about is, okay, if I have a product recall or if I have a customer complaint, what is that going to cost me? So a lot of customers are investing in this technology as a way to ensure their brand. So in summary, vision can be a tool to help you manage your process, get a lot of data about your process. It can actually be a rejection mechanism to take product off the line that you don't want going to your customers. It allows you to remove inspectors from the line, which is a very tedious job, and have them do some other more productive things. But it does require some management. You have to, clean the optical windows, especially the bottom one, because we know dirt falls down. So there is some level of requirement, and there's also a level of training required, but it can be a very powerful tool when used appropriately.
Thank you, Andrew. Thank you. It just brings me back to the days of my Wendy's New Bakery quality checks and how fun those were. Just 6 months took like 30 minutes.
Exactly.
Totally get it. Now, I'm sure everyone has, some questions in your mind on, well, if I install a vision system, won't the rejection be really, really high? So my response to that usually is, well, you can't just put a yes or no system at the end of your system. You need to also determine what's ahead, right? And how do you control the quality right at the mixer before it goes to be rejected, right? So the problem is right here. So that's what Lena is here to explain. So Lena, why don't you take it away? How can we control it so that we don't reject, 80%, right?
So yes, no, that's a perfect introduction. The idea here is that vision inspection systems are great in order to follow up your process performance and to reject faulty products. But what we want to do is to avoid faulty products altogether. And to do that, we need to have a good control on the production and on one of the main functional ingredients, which is flour. Now, to know that, to be able to do that, to have a good control, then we need to know what is the first step is to know what is a good product. And again, this can be achieved thanks to vision inspection system, but the thing is that there is not one unique good final product. That really depends on the production, on the product that you are making. A good hamburger bun for I don't know, for Americans or for French people might not be exactly the same in terms of sugar content or fat content or looks or whatever. So the idea is that there are different types of buns. And of course, then you can also consider that you have gluten-free buns, that you have keto buns, that you have enriched protein buns, and so on. But you have different final products, and that's the idea. And before the final product, you have the entire process. And the process contains many, many variables. There is not one factory that is the same as the other. They are all unique in the recipe, in the process, in the machines that are used, in the temperatures and the timings that are used in between the steps. And of course, there is always the human factor, even in the most automatized line of productions. And then there is the flour. And so we need to be able to select a good flour that would correspond to the specific, oops, I have an issue with my animation, but that's okay. So, but we need to be able to select a good flour that would correspond to your process, that will not, I don't know, sticking everywhere, even though that could be very good news for good way. But yeah, you want the process to go smoothly, and then you want the final product to be perfect and reject not as many, but as less final product as possible. And to do that, you need to create your own specification. What we believe strongly is that the flour quality should be specific to each baker, taking into account the final product characteristics and the process characteristics. But oftenly, what we find is that industrial bakers rely on specifications that has been built thanks to literature or according to millers. And this is a good indication. And this is basically the kind of information that you can find online here. I just asked to ChatGPT what should be a good flour for making hamburger buns. And ChatGPT told me that basically you need a bread flour and you need a high protein content between 12 and 14%. So I'm not saying this is untrue. I'm just saying that it's a good indication that maybe it is not enough. And maybe it does not integrate the differences between the different baking plants and the different final product. What we consider here to be a better solution, a better approach to control your flour, control your process is, as Andrew explained very well, is first we need to measure the process real performance. We cannot rely anymore on 6 buns every half hour. We need to understand the entire production. We need to understand how the recipe and the process impact final product by analyzing the dough from the line and define the dough characteristics from this line, set up specification for a good dough and follow its consistency to be able to react as soon as possible before it's too late, before the final product is done. And then according to this experience, we can define the best flour that will run smoothly in the process and give a good final product. And this can be done very easily, very empirically, thanks to rheological equipment such as the mixer lab. Thanks to that, you can finally give your miller specifications based on actual measurements that are really working for you. Designed by you and for you, and that really reduce the weight of empirism or what we can find in the literature again. And that actually allows me a nice opening at the end that actually resembles the one that Andrew did, is that, well, what we can measure, we can improve. And here we can measure the entire process and we can put data on every step of the process. And data is the food for artificial intelligence. So if you apply such process, then you are basically ready for the future. You are ready for the next revolution of artificial intelligence. So in the end, what we believe is that bakers and hamburger bun producers, they don't need machines, they need solutions. Solutions adapted to their needs. And here, as KPM, we can really apply a solution to control the entire process, starting with the end product, objectively putting data on what is a good product or not, and measuring each key aspect of the final product. We can reject faulty products if it's necessary, of course, thus ensuring the final consumer happiness. And then before that, we can go back to the line of production, analyzing the dough at key steps of the production, thanks to rheological tools such as the mixer lab, measuring objectively its consistency, not necessarily relying on human operators who are touching the dough and saying, yes, this is a good dough, or no, it requires maybe 0.5% more water. Those, I'm not joking about those people, because those are experts. This is just that it's taking years to develop this kind of expertise, and it's very difficult to find and to replace. Here we have a way to complement this experience thanks to objective data. And finally, thanks to the same tool, the Mix Lab, you can also analyze your flour, and you can build specifications based on what is good for you on all aspects of the flour, both protein, but also starch and interactions. And with that, thank you very much. And well, questions?
Awesome. Thank you, everyone. So my comment is, I was, just in another plant a week ago, and they shut off their vision systems. And I asked why, and said, oh, we're just rejecting too many. We're just rejecting too many. And I asked, well, are you looking at your flour specs? And they're like, no quality control anywhere and on the front side of the process. So that's where the problem is. You can't just turn it on. You have to make sure the entire process goes smoothly. And this is important. Let me tell you why. Because we are going into an age where we no longer have the expertise, like Lena said, at the mixer, right? Eventually, we have to AI automate the whole thing. And you have to start right here, right now, today, as we speak, on gathering those data points. Because once we have those data points, we can definitely automate the entire system. Okay, so yeah, let's go into Q&A, everyone. Oh, yes, I forgot. We do have a Hamburger Bun production white paper. And if you scan this code, you can download it today and get more information on how to improve your Hamburger Bun production. Of course, this is sponsored by KPM Analytics.
So as I mentioned briefly, obviously keeping the optical windows clean is important, but it's not a super onerous task. The bottom camera should be cleaned once every shift, just wiped clean with a clean cloth. We have some design features, the angle of the window, some air nozzles to keep it clean so that it doesn't have to be cleaned every 5 minutes. The upper cameras, because they're facing downward, it's not such an issue. Cleaning those once a week is more than enough. From a maintenance point of view, there's nothing. It's really just a conveyor with the cameras synchronizing with the encoder on the belt. So maintenance is not very high, but cleaning the cameras is key. But a key part of any installation of any technical piece of equipment is having your people well trained. And typically at each facility, we try and have the customer identify 1 or 2 people at that facility that we can train as key users. All the operators will get trained, but the key user will get a little bit more training, because things like setting tolerances for each individual product. For a product that's going to the supermarket, maybe you don't need as tight a range as the one going to your most important QSR customer. So you can set those tolerances differently for those different customers, and they're saved. And you can also decide what attributes are important and what aren't for each product. So again, having an operator that understands how to make adjustments, you can even make adjustments while you're inspecting, is very important. So you need to have somebody at least responsible and trained so that they will be able to be a resource for you to do that yourself in-house. We're always there remotely connecting for support if required, but obviously it's better if you guys can do it in real time in your facility. So that's a very important part of the process.
Yeah, absolutely. You can reach out to us anytime. We offer on-site demonstrations anywhere in the US, Canada, Mexico, Europe, as well as many countries all over the world. So yes, please get in contact with us. We'd be happy to visit your bakery and help you out.
typically it all depends, moisture level, the development of the dough, the conditions of the proofer. There are 1,000 things that can really contribute to the quality issues that you're talking about, having wrinkles on buns. And so, and even, how much humidity or lack of humidity in the cooling process as well. So they're all things that you need to understand. And the good thing is with, a vision system, you can objectively measure those things and see when there's a change. But even some of the real subtle defects, it's a, I wish buns was really easy to make. It's not making widgets. It's a process that's alive. The yeast is alive. The environment changes. It's a very challenging, as you guys know, I don't have to tell you, it's a very challenging process.
Yes. In addition to that, what happens when something rises a lot in the oven spring? It just basically collapses when it cools, right? So what happens when you collapse? When you collapse, that's where the wrinkles form, right? So number one, take a look at your oven spring and make sure that you don't get too high of an oven spring. If you're getting more than 20%, I would like to get probably 1 to 3% oven spring because I'm that kind of controlling person. But if you're getting a lot of facilities are getting 10, 20% oven spring, they're trying to get the height in the oven. And that is very, very wrong. You should never get height in the oven. You should always get the height in the proofer. And this is why, instrumentation and data collection is so important. Always meet your height in the proofer, get all the yeast, expand their energy, finish fermenting in the proofer before you bring them into the oven. Once they're in the oven, kill them fast, right? Then you won't get any oven spring, because the more oven spring you get, the more they collapse and the more of the wrinkles you get. And then when you get the wrinkles, there's this extra space on top that will peel off. So
and then you also have the risk of, break and shred and things like that, which is another problem. You don't want it popping in the oven, tearing the dough, and now you've got something that's quite ugly or sloped or something like that as well.
Absolutely. So take a look at your oven spring, and the number one thing to reduce the oven spring is increase the front zones of your heat or reduce the amount of yeast you have in there. Hope that helps.
Yeah, so we've had several customers in the last few years ask us that question, and we've done really thorough testing. And we're able to very effectively remove those seeds from the inside of the links of the belt. So it does a great job doing so. And we're actually able to pass sesame seed allergen swab on the food contact surface after the cleaning is complete. So not only does it remove the seed, but it also removes any trace amounts of allergen that are left behind from the seed, maybe a little bit of oil or things like that. So yeah, absolutely.
Excellent, excellent. And one of the things I want to make a comment on, back in the days before we had your technology, Evan, we were just shooting seeds in the air. We'll just blow them off. And that is not sanitary. And if you're doing that, you got to stop doing that. So we now have a perfect solution for that. Just come to contact Evan. Yeah.
The answer is no. You're totally in control of the inspection system. So again, as I mentioned earlier, you set the tolerances, and typically what we say is when you start using your inspection system, don't turn the rejection on. Just collect data. You collect data for a few days or a week. Now I have a really good picture of my process. And don't forget, my process hasn't changed. It was the same before I turned the vision system on, and now after it, it's still the same process. And as I said, I was sending the product out to the customer, and by and large, it was acceptable. So that's a good place to start. Start there and set your tolerances based on the data. So if I know my height is from, 45 millimeters to 55 millimeters for, 90% of my products, then that's where I should be setting it. We strongly recommend that initially you would never set the customer specification as the rejection criteria, because it's typically not based on processing parameters. And I've been a supplier to McDonald's, and I know how tough customers can be. Well, our spec is our spec no matter what, but we were able to share the data with them and show them what was really going on in the bakeries, that's when I said, you know, our minds all blue, including McDonald's. We said, look, we have this process and we've been using this for 5 years and it's been fine. So, but we can use this tool of a vision system now to narrow the range and get to where you are. Change our process, as I mentioned, you know, more batches, smaller batches more often, reduced our variation. So that helped us to narrow the process variation. So the tool with vision is to be able to narrow the range of the variation to actually help eliminate waste or reduce waste. You'll never eliminate it, but you can reduce it. So it's all about understanding your process, being sensible about setting your tolerances, and again, focus on what's important to the customer. You can set tolerances, measure lots of things, and you can set tolerances for lots of things, but unless it's important to your customer, why do it? Why set tolerance? You can still collect the data and look at the data for that particular attribute, but, you know, focus, you know, bake color, sesame seed coverage, height, so that it toasts properly in some facilities, in some QSRs. So that's, you know, what we always recommend. And you know, we have lots of case studies where we can share that to show, okay, this is how we worked with that customer to, you know, to get a great outcome, a good trade-off between meeting the customer specification and not increasing waste excessively.
That's a great suggestion, Andrew, in terms of turning on the data. And I believe if you do that, you're going to see, oh, well, the first shift is doing this, the second shift is doing that, you know, who's on position at the mixer and who's causing this, right? I think you should be able to do that correlation. And that's why what Lena has suggested is really important, to do the quality analysis at the mixer and then correlate those two things. And some people may think, wow, that's just really too much work. You know, what is too much work is throwing away all those things and not meeting spec to your customers, say a McDonald's or a Wendy's. They depend on these vision systems to really approve the products that you ship to them, right? So that is so important. Figure out where the problem is. The problem is really not your vision system. The problem is who is in charge of the mixing process, the baking process, the fermenting process. And that can only be understood when you collect your data and you correlate properly to the final vision system. So, Lena, do you have a comment to make about that? Did I say it right?
No, this is great. Maybe just that it's not necessarily a lot of work, actually. Because setting up specifications all rely on your process. I mean, to set up good specification, we recommend to have at least 20 analysis of a good dough. But thanks to our system, 20 analysis, it's done like that. Those are 2 minutes tests. So that's actually very easy to set up specifications. And then, of course, we always need a first phase to challenge a little bit those specifications to make sure that they are able to identify those that are not conform or that will cause issues. But it is just about observing. So that's fast and quite easy to do. You don't need to be high-level scientists, 2 PhDs and so on to understand what's going on. You just need to look at things and make the link.
Right. Thank you.
Yeah, as I mentioned earlier, we're really big on training and support for everyone in the baking industry who decides to implement our systems. So we have a team of sanitation experts all over the world. They would come into the facility, provide training to make sure that your bakery gets up and running with the equipment effectively. And then we also offer service everywhere that we provide equipment to make sure that we're able to send technicians for any maintenance that's needed or repairs down the road. So we're very big on supporting our customers, and we get in the field and we help them out very closely.
Typically that has been in the past, you know, the last point of check before it goes to packaging, just to make sure that there's, you know, only the good stuff is getting packed. But as I mentioned in the presentation, we're doing a lot more vision process control now. So using a simpler vision system at different points in the process, so that we can, you know, have better control of the process, set off alerts so corrections can be taken earlier. And then in some particular applications, sometimes inspection's done after the oven rather than after the cooler, just because that's the customer's preference. But again, anywhere there's a process to be measured, vision can help you with that. It's just a matter of always, where again is the most value for you in the inspection. And different products have different points where this is really where a make or break a point. This is a critical control point for quality. And so sometimes that's the place where they want to do the vision. And maybe it doesn't have rejection at that point, but we're getting data, we're maybe even doing a feedback loop to control the process, or at least maybe having an alarm or alert so that if something is not where it needs to be, okay, somebody can be brought to have a look at it.
Yeah, and I would really recommend a final checkpoint, especially before you put the product into the bag, right? Because there's so much that could happen between the oven and the packaging, So we're talking about sanded heels, you're talking about conveyors, You're talking about contamination, you're talking about small little slice blades that will go wrong at any time. So, just having that in mind it's so important to just catch at the last point before you bag it. So that's my recommendation as well.
And I think your point is valid, Lynn. I would say that even where we have vision process control, there's always a final inspection prior to packaging. That's the final point. The other ones are just additional vision that can help control your process. But I agree with you 100%.
Correct. But ultimately, I think this question comes from a point of view that could be something wrong in my oven. So that's why you need to collect data at every point, like what Lena and Andrew has been talking about, right? Just keep collecting the data, then you don't need to really worry about it. Don't need to worry about the rejection. Okay. So, well, this has been a really interesting session, and I'm sure everyone here really appreciates your expertise. So thank you, Andrew. Thank you, Lena. And thank you, Evan, for coming on today. And thank you, Ashuni. Thanks, everyone, for taking time out of the day to come and listen to this. Have a great day, everyone.